When Elon Musk's SpaceX, short for Space Exploration Technologies, got into the rocket game, it promised reusability, lower launch costs, and easier access to space. Over the last few years, the company has taken steady steps to making good on that promise, thanks in large part to the success of its Falcon 9 rocket. Don't forget to watch today's video in full to get the full scoop on Elon Musk explaining the SpaceX genius new stage separation system. Truckload of ambitious plans. Assuming it all goes to plan, SpaceX has big plans with its new rocket. A crewed flight around the moon with Japanese billionaire Yusaku Nozawa is scheduled for 2023, while Musk is aiming to establish a full-blown city on Mars by 2050. It's not the first time that SpaceX has suggested using the Starship to clean up space. In an October 2020 interview with Time, company president Gwynne Shotwell said that it's quite possible that we could leverage Starship to go to some of these dead rocket bodies. Other people's rockets, of course, basically, go pick up some of this junk in outer space. It's not easy. It's not going to be easy. But I do believe that Starship offers the possibility of going and doing that, Shotwell said. Launch vehicle separation strategies. In rocketry, there are generally two distinct types of launch vehicle separation strategies. All require some kind of actuating latch or frangible bolts to attach and detach stages. The differences arise during stage separation. Some rockets, particularly Russian vehicles, rely on hot staging, in which a separating stage will ignite its engine slightly before or at the same time as it's released, blasting the stage below it. More commonly, rocket upper stages are jettisoned a significant difference from lower stages before igniting and heading towards orbit with either small solid rocket motors, small vernier thrusters, or, in SpaceX's case, spring-like mechanisms that can be tested on the ground and reused. In the first two parts of a three-part interview with YouTube creator Tim Dodd, SpaceX CEO Elon Musk has delved into two new Starship and Super Heavy mechanisms that take his pursuit of simplicity to new extremes. Around the turn of the month, Starship's first flight-worthy Super Heavy booster was outfitted with a niche form of aerodynamic control surfaces known as grid fins. Those multi-ton car-sized fins have been expected ever since the original form of Starship was first revealed in 2016. What was unexpected, however, was the fact that Booster 4's grid fins quite clearly had no retraction or deployment mechanism and were instead fixed in a deployed position after installation, foregoing all separation mechanism. Meanwhile, just a month after SpaceX performed a partial test of the mechanisms, meant to latch Starship and Super Heavy together and deploy the ship in flight, Musk says that SpaceX has also decided to almost entirely remove any recognizable separation mechanism. Sidestepping decades of precedent, Musk says that Starship will have no separation mechanism at all. Instead, at some point during the design or testing process, Musk decided that a separation mechanism was entirely superfluous and that the same effect could be more or less replicated by using existing systems on Super Heavy. By using the booster's Kimballing Raptor engines to impart a small but significant rotation on the rocket moments before separation, Super Heavy could effectively flick Starship away from it. A bit like how SpaceX currently deploys Starlink satellites from Falcon by spinning the upper stage end over end and letting the spacecraft just float away thanks to centripetal forces. Because Starship is something like 5 times heavier than Super Heavy at stage separation, the ship would effectively float away from the booster in a straight and stable line. Use cold gas thrusters to settle its propellant and ignite its 6 Raptor engines to head to orbit. In return for the slightly unorthodox deployment profile, if this new approach works, SpaceX can entirely preclude the development of a pusher/spring system capable of pushing a 1,300-ton Starship away from Super Heavy. That approach is possible on Starship in large part because the ship's 6 Raptor engines are completely tucked away inside a skirt, meaning that there is zero chance of nozzles being damaged by impacting the booster interstage. The situation with Super Heavy's grid fins is not dissimilar. Importance of having an interstage pattern. An interstage is vital to any multi-stage rocket. This section connects the first and second stages and also houses the engine of the second stage, protecting it during the first phases of flight. At the right moment, the interstage separates the two stages, allowing the second stage to fire safely. This is called the moment of staging. Separating rocket stages can be a tricky business, but the Falcon 9 makes it simpler. While the majority of rockets use a complicated pyrotechnic system of explosive bolts to separate stages, SpaceX uses an all-pneumatic stage separation system. This system can be tested on the ground and also means staging is less jarring to the rocket. SpaceX's Starship launch system. SpaceX has achieved another major milestone in its Starship fully reusable launch system. It stacked the Starship spacecraft itself on top of a prototype of its Super Heavy booster, which itself is loaded up with a full complement of 29 Raptor rocket engines, and the Starship on top has 6 itself. The stacked spacecraft now represents the tallest assembled rocket ever developed in history. This stacking, which happened at SpaceX's development site in South Texas, is a significant development because it's the first time the two elements of the full Starship system have been united as one. This is the configuration that will be used for launching the next Starship prototype on its test mission that will hopefully achieve orbit. Taken together, the massive combined launch system reaches nearly 400 feet tall, around 390 feet, to be more precise, and combined with the orbital launch stand on which it rests, the whole thing is about 475 feet high, which is taller than the Great Pyramid of Giza. The stacking itself is impressive, but don't expect it to last. The likely next step is for the two halves of the launch system to be separated again, with both undergoing more work, analysis, and testing ahead of a reassembly in preparation for the actual eventual orbital launch test. As for when the orbital launch test will actually take place, it's not currently clear. The disassembly, testing, and reassembly will take some time, but the company is definitely still aiming to make that happen before end of year. SpaceX CEO Elon Musk then revealed more details about what's next for the Starship system after the two halves are separated. In a tweet, he said that next up for the system will be adding the final heat shield tiles on the Starship spacecraft, a task that is around 98% complete. He added in a tweet, "The other items on the to-do list are adding thermal protection to booster engines, ground propellant storage tanks, and a QD arm for the ship." Of course, that's not all SpaceX needs to do to get Starship flight ready. Receiving a launch license from the Federal Aviation Administration. That can't happen until the regulator has completed an environmental assessment, a process that could take months. Reading into the system further, SpaceX's Starship system represents a fully reusable transportation system designed to service Earth orbit needs as well as missions to the Moon and Mars. This two-stage vehicle, composed of the Super Heavy rocket, booster, and Starship spacecraft, is powered by subcooled methane and oxygen. Starship is designed to evolve rapidly to meet near-term and future customer needs, while maintaining the highest level of reliability. Starship has the capability to transport satellites, payloads, crew, and cargo to a variety of orbits in Earth, lunar, or Martian landing sites. Potential Starship customers can use this guide as a resource for preliminary payload accommodations information. This is the initial release of the Starship User's Guide, and it will be updated frequently in response to customer feedback. SpaceX's Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, represent a fully reusable transportation system designed to carry both crew and cargo to Earth orbit, the Moon, Mars, and beyond. Starship will be the world's most powerful launch vehicle ever developed, with the ability to carry in excess of 100 metric tons to Earth orbit. Starship has a height of 120 meters, a diameter of 9 meters, and a payload capacity to LEO of 100 tons. The Starship payload fairing is 9 meters in diameter and 18 meters high, resulting in the largest usable payload volume of any current or in development launcher. This payload volume can be configured for both crew and cargo. Payload volume: 1,100 meters cubed. With that, we come to the end of today's video. Don't forget to join in next time for more of such interesting content.